Hi. Today's presentation is about messaging and CQRS. Okay, it's a way to decouple your application using framework like Kafka or anything, but here I will use my simple bus that I have made earlier. Then you will be able to see how we can just use and play and learn from messaging with simple example. Let's say, like I said, it's about implementing CQRS, DDD aggregate, and messaging. All of those patterns, you will see a lot of stuff about that. The context is I'm at the grocery store and I want to put apple in a range in my cart. That's it. It's basically going through that example. A point here I will use it's like an hack. If we look from Martin Fowler application controller, it's a centralized point of handling screen navigation and the flow of the application. Okay, at some point it's handling the flow of the application. Okay? Messaging is about that. We will use that hack, that pattern application controller to know more about that. It's an hack. If you look at a way that an aggregate could be like a controller, it could be like a mediator, a state machine, or even an interactor. Okay, it's all those words saying the same thing. You will control the flow of the application. Okay, all based on that. Okay? We can use, if you are in a monolith application and you want to move on microservice, we can probably use that kindly hack to move on. How it will do? Then you will receive a message. At same pattern like a web, you are on a page, you post something on your application. Okay? REST API, the same pattern. Then you send a message to your application. And on the other side, you have an handler that will receive that message and will do some stuff on it. Okay? And then, why not using back again in your controller like something that you can push or post a new message. Like if you have many applications, then you will communicate in between applications with HTTP requests. I post and get. Okay? Then you have a message, you have a controller, it will produce a new message and you will send to another controller. And why not this one produce two messages? This one will affect this controller, this one will affect this one will produce, this one will stop there. Why not? Okay? Like I said, it's an hack, it's not a good way to do stuff, but at some point we can use that pattern to try to think how we can module our application to make it more scalable, flexible, and decouple at some point. Let's go with that presentation. Have fun! Like we see earlier in the presentation, today we will go over into an example of CQRS messaging, something simple like I'm at the grocery store, I want to pick some apple in a range. Okay, first you have seen probably in another tool that I have made some kind of simple bus. I'm just getting it back and just using it. It's a way to get something easy to do. Okay? Don't have to put Kafka or some big hard stuff here. Just have to put a simple bus and that's it. So first, in my story, I said that I have to put something in the cart. Then probably somewhere I will have some kind of cart repository. Let's say I have a cart repository. Okay, a repository is where I will put my stuff in it. I will probably have a method that I want to add item. Okay, then I will just put into my cart some items. Okay, that's fine. Then I want to initialize. Then when I create my cart repository, I just want to have some items that I can put in it. That's fine. Okay, then I just want also to see what I have in my cart. Then probably I can just add a method to define a list. There is some item in my cart, okay, or are. There are some item in my cart because. So, okay, I have a repository. Then if I'm in CQRS, then I will have to send command that will create an event out of that. What I can do now is I have to create a command and an event. Okay, let's say I will have a class, which I can say, I pick an apple, an apple command. Okay, basically for this presentation, it will be simple as just having an ID, a payload, and a correlation ID. The correlation ID, it's another subject, but it's sometimes when you have a bunch of objects, both of command and handler, command and event, and you want to be able to retrace, to group them all, to know how this belongs to this one, then you use the correlation ID. It's a way that it's used. I can also use define an apple picked event. Then I will send a command to pick an apple. This would generate that I picked an apple. So for that, it's not just like this. I had to add some handler. When I will send a command, something has to handling the stuff. Then I can have just for naming pick an apple command handler. Then, like I said earlier in another post, a quick trick to do here could be to have a handling of pick an apple class. Then this will bind on this, and it's in the handler repository and in the bus that we will make it. We will tie them together. So what I have to do to add next, I have a handle. I want to handle a command. Then here for just to start, I would just set just a display. On the other end, I also have the same thing for the apple picked up event. Okay, when it's an event, the same thing. I'm tied on the pickle event, apple picked event. Then I will just print some payload. Okay, then like I said, if you have seen the other post on my simple repository, we have to tie them up. Then I create my handler repository where I will put all my handler. Then I now add to register them all. Then I have pick an apple command handler, and I have an apple picked event handler. That's fine. And now the magic is here. I want to send an apple picked event. Then what I can do is I want to create an apple command, then a pick an apple command. Then that's it. And for my example, I would just go straight forward, just setting an ID, simple ID. Okay, then I will send the command. If we run this, okay, nothing is printed. So back, I just forgot that here it was a program. And this code is name. If I go in my event, when I do handling of, I have put classes, but it's name. Then it's the way to bind stuff together. And if I run my stuff now, my code now, then I go into my pick an apple handler. So back again, I just send a command, and then it's just the handler that's printed. But what I want to know is what I have in my cart. Then I have to use my cart repository and to list on it. So for doing this, I just have to add my cart repository instance, and then I can hit run again. So that's fine. There's no item in my cart. Yes, because I didn't tie or do something with the event that should add an item in my cart. I just create a command that do nothing, and then I have to make it works. Then when the command will be sent, it will produce an event. Then on event, it will add my item in the cart. Then it's the cause and effect. I pick an apple, then the fact of picking an apple create an event that is apple picked up event, and this will result as having something in my cart. Okay, you follow me? Let's go with this example. So now we have seen that we send a command. Okay, that's fine. Then there's nothing in my cart. We have to bind it to that. Okay, then we can use just go back into the for the event handler and add the cart repository in the event handler. Then to do so, we have to define and initialize where we will inject the cart repository. Okay, if you want to know more about dependency injection, I refer to Robert C. Merton, known as Uncle Bob, about dependencies injection, or you have any kind of IOC container that will help you, like an inject or an enjoy inject or a castle project, and a lot of things like this. We'll go over in a bit. Just by doing this, you are making your code more dynamics. So, okay, I add my cart repository. Then what I have to do is when I receive an event, I just have to add an apple into my cart because it's apple picked event. Okay, then I have to go back in my handler here, and then instead of just having apple picked up event, I also have to add the cart repository. And okay, I have my cart repository. When the apple picked up event will occur, then I will have to do something with the cart. So this is just one part. We fixed the event side, but the command has to do something. So what we can do is we can do like an act, like I presented in the previous demonstration or in the intro. Okay, from the application, from Martin Fowler application controller, we can see that a controller could be like an aggregate, a mediator, an interactor. Okay, a controller is a centralized point of handling string navigation and the flow of the application. If you look at the flow of the application, it's like a mediator. It's the same thing. So we can use that pattern here to do an act. We are doing web, yes, then instead of having controller everywhere, we can just post something onto the route that we have and then use the controller to do an act. Okay, sometimes it could be nice just to have something easy, and we can gain some speed by using this. So we will use cart controller. Following this, we will have to inject the bus, because we will receive like a command, and this command will be reinterpreted as an event. Okay, it's like a transformation. So when the command will occur, will be sent to add an apple, it will call the controller to add an apple. This will generate an event. So let's go like this. Add a method called an apple. Whoops, here. Okay, I add an apple ID at item. This will generate as transform as apple picked up event. If you have an aggregate, you will probably do the same thing. By adding an apple, you will generate events related to that. Okay, it's a way to do some workaround. It's an hack. Okay, it's kindly an hack. So next, what we have now to fix the command handler. Go back to the command handler. When we have the command handler, we no more just can do a new here, because we have to inject the bus it's always the same thing. Using dependency and inversion, you transform your static code to a dynamic code. Then for that, we have to where is my code? Here. I have to inject the card controller in the command handler. Okay, that's fine. I add the card controller here initialize. Then when I will handle the command, I will just call my controller. At some point, we can also do a post. Then we can just create an HTTP post, and then we just post a command, a result or something over the web route, and then it will generate a route. But we can do it also a backend like this by just pushing some stuff, and then we are at some point decoupled from the system also. Okay, we push the command ID and the payload to the add an apple. Okay, come back here, ID item, then we will transform it to an event, and then we will be able to go with this. So what we need now, like I said, I will just add a note here. We are using dependency injection principle. Okay, we can use the bus instance instead of creating a new one each time. Okay, if you want to know more, have a look into the solid Robert C. Martin. He talked about this pattern if you want to dig more. Okay, doing new everywhere is a bad practice. It makes your code static. You tie some unwanted behavior together. Make your code dynamics. Have a look in an inject or Castle project, IOC container. There's some in C# also. Then, okay, let's go back to our code. I have my card controller. That's fine. Okay, that need a bus. The bus is declared after. Then I just have to put. Let's say we move those one after here. They need the bus. The bus is declared before. That's fine. And then I just have to update my pick an apple command handler to push my card controller. So will have something in my card? Probably yes, because I will send a command. The command will be transformed, will call a controller. The controller will transform it into an event, and the event will act on the repository that it will add an apple in there. Just have a look here just to be sure. I add an apple in my cart repository. I have a method add in it. Yes, I have a method that will add, and it will list something. Let's run. There is one item in my cart, an apple. Fine. Okay, if we go here, we went to a command handler, then we transform it to an apple pick it up event handler, and then there's an apple in my cart.